Hello and welcome to my new video. We are going hands-on with hashing, a one-way transformation used for integrity and authentication. I'll walk through different types of hashing and show how tiny input changes produces completely different digests. Hashing uses mathematical function to transform data into a fixed length value called hash. The key property of hashing is that it is one way. You can hash data, but you cannot reverse it to get the original input. Hashes are often used for data integrity and verification. For example, servers store the passwords not in their original form. They are kept hashed. When the user logs in, the server hashes the entered password and compares it to the saved password. And if they match, the login is successful. So typical usages of hashing are integrity checks, password storage, message authentication, and files identification. Common hash algorithms are MD5, SHA1, SHA256, HMAC, bcrypt, scrypt, and others. Hashing is a one-way transformation. It takes any input like text, file, or bytes and produces a fixed length output called hash or digest. Unlike encryption or encoding, hashing cannot be reversed to receive the original input. Even a tiny change in input radically changes the output, which is called avalanche effect. For hashing, I've also prepared a sample code to see how it works. In this demo, we compute SHA256 for a string, then change just one character and hash it. You will see the digest completely change. I'll also compute MD5 to show the difference. It's fast and short, but it's not secure anymore, so don't use it for any protection. And finally, we compute an HMAC SHA256 using a secret key. With the same message but a different key, the HMAC changes. This proves that HMAC provides both authenticity and integrity. If the key is hard-coded in APK though, the attacker can recompute valid HMACs, so don't keep the secrets inside the APK or keep them in a Keystore. So what do we see in the logs? We see SHA256 for a sample text. This is a 256-bit digest of the original string. It's fixed length and looks random. We also see SHA256 for sample text plus dot. We changed just one character, added a dot, and the entire digest changed. That's the avalanche effect in action. We see logs for MD5 for a sample text. MD5 is much shorter and very fast, but it's not secure for anything sensitive. This can be used only for non-security checksums. And we also see HMAC SHA256 for a sample text with one key. And we see another log for HMAC SHA256 for sample text with a different key. And with the same message but different key, we see the completely different output. This shows that HMAC depends on the secret key. And quick summary for hashing. Hashing is not equal to encoding or encryption. It's one way and cannot be reversed. SHA256 is good for integrity checks since it detects changes. MD5 and SHA1 are outdated and avoid using them for protection and security checks. HMAC SHA256 adds a secret key and it's good for integrity and authenticity. So that's it for hashing, a one-way transformation used for integrity and authentication. If you like this video, please put your like and subscribe and leave your comment if you have any questions or suggestions. Thanks for watching.